All right. I'm going to use Dspy because it's a great way to structure our AI programs. And at the same time, getting great performance out of it's difficult unless we're using an optimizer. But using an optimizer requires a data set and a metric. And so, one of the challenges with building a great AI system is early on, we don't really have a way to just write a metric as code. And so I see a lot of people get tripped up by this, but there's kind of like a simple way to get through this. I'm going to walk through this like in real bare bones way. Um, and another live stream will probably build on top of this as well and show you how you can extend the idea of having a human in the loop metric to having a system which helps you get to an automated judge very quickly. So, with all that being said, let me just go ahead and check that the sound is working. Cool. Sound is working. So let's get started. So first thing we need is kind of like a data set to start and just something to work with. So we're going to use this emotions data set on Hugging Face. And so really easy way to use this data set. So we can just go ahead and copy this. So I'm just going to use pandas. It's pretty simple and straightforward. So let me go ahead and start just by adding some of the dependencies we're going to use. So obviously we're going to use Dspy. We need to zoom in one more. And then obviously pandas because we saw that. So let's go ahead and do that. And I'm also going to add IPyKernel and IPDB because I tend to use those a lot. And we'll go ahead and just create a little notebook, just something to let us like quickly explore our data set. Oh, does not look like it recognizes our okay, so this doesn't recognize our VM because we have like a nesting here, but that's fine. We will just do it in here. So we'll go ahead, create a main function and just create a main guard. And so basically what we're going to want to do is import pandas, and then we're going to do this, and then we'll just want to, output like head here. So it's good. Well, later we'll also need to add environment variables, and we'll use python.in for that. But for now, I think we're good. So we can go ahead and just run this and just make sure that we're able to access the data set appropriately. This will take a little bit of time because behind the scenes it has to download the data set. The data set is not that large though. It's about 7.5 MB. But yeah, so we see that we get a sentence and we get the label. So we do have a label here, but let's just for the sake of the example, we're gonna like assume we don't have the label and kind of like put it in ourselves. So really all we care about here is getting the sentences, and that's gonna kind of like construct like our data set essentially. So we know how to load it. Now let's talk about like what we want to do here. We really just want to basically have something that takes a sentence and then outputs a label. So another thing I'm going to want to do is understand like what are the possible labels that we can have. And so, the other thing we might want to do here is say df label, and we'll do value counts. And this will give us an idea also of the prevalence of each label. And this should run much faster just because the data set has already been downloaded. So we see we have happiness, sadness, neutral, anger, love, fear, disgust, confusion, surprise, shame, guilt, sarcasm, desire. Cool. So got a lot of things here. So now let's get into like Dspy and see how that kind of works. So if you aren't familiar, I'm just going to go like straight from the top. So if you're trying to learn Dspy, there's kind of a few different things you want to familiarize yourself with. The first thing is signatures. So a signature is basically a way for you to describe your task. You're basically in a very simple way describing what are the inputs of your program and what are its outputs. Modules take signatures and implement certain ways to do that task. And then optimizers will make modules work better. So, one of the most basic modules that you'll use is just called predict. And that just behind the scenes, really what it's doing is it's crafting like a very simple direct prompt for your task. But because it generally doesn't have any domain knowledge about your task, it just has like the straightforward description, it might not work that well. So we're going to jump in and just like see what ways we can do this. But one way we have is just to use the text. We can also provide instructions, and this is something that ends up being essentially like a prompt. But we can also use a class base. So it's great that we actually have this as an example because this is pretty close to what we want. We want to classify motion. And so I'm just going to go ahead and copy this and we can reuse this. Let me just make this a little bit smaller and close that off, so we get some more space. So obviously we need to import dspy here. And we have this dspy signature with a sentence, so it's good, input field. And we know here that we have some different things we'll have, but what I'm going to do here is just create an emotion label to like capture all of the different emotion types we can have. And so we know we have happiness. Let me just like copy this. And then we can just like ask cursor, make a literal with all the labels in this value counts output. And so desire, sarcasm, guilt. Yep, looks like they're all there. So now we have like our emotion label and we can literally just do this. Cool. So we have like the most basic thing here. And so now if we wanted to have a thing to classify emotion, we have our signature here. We have a signature here with this emotion class. And so this is just specifying how to, yeah, like what our task is. But we can't really use this directly. If we want something to use it, we need to apply a module. And so, like I said, the predict module is the simplest one. It's a very common one. So we can go ahead and do that. And so now I'm basically just going to do like the dumb simple thing and basically add a oops, I'm going to add a column which basically is predicted emotion. And then we're going to do this. And we can now print out all those same things. We don't really need the value counts anymore, but one thing that might be interesting to see is what is like how often is it that we get the same? So like what is the accuracy of our prediction? And so what we might do is say df label. And so this is going to give a Boolean. And so we can basically say as type int and then take the mean. And actually we probably want to do float so that this comes out to be thing. So one thing we're actually missing, um, this is going to use an LLM, and we haven't configured an LLM to use. So when you actually like want to use it, um, you need to like somehow like set up or configure a LLM. And so if we like just go to like um, tutorials, well, it really only has agent tutorials. That's interesting. So we'll just like look up there. There's like a way to configure this. Mm-mm-mm. I just forget how to do it. Mm-mm. Learn Dspy. Maybe it's under here. Programming overview, language models. Ah, here it is. So use dspy.lm. Um, and so there you go. So this is sort of the thing we need. So we're going to use GPT-4o mini, but that means we're going to need our key. And I don't have that there yet. So what I'm going to do is first, I'm going to like take from my current environment. I'm going to grep for the OpenAI key I have. And then I'm going to write that out to a .m file. So now I have an OpenAI key there, but because it's in a dot file, we're going to need to apply that dot file in our program. And so go ahead and add the dependency, and then we can say from .env, load .env, and now we can just load our dot environment. So now after this point, now we have that key loaded in. We've configured which LLM to use, which language model, and we should be good to go. Now, this could take a while just because this data set's very large. So what I'm going to do here is, just before we even get into this, I'm going to make a load data set function. And we're going to do that same thing here, but I'm going to return just the first, not even 100, let's just say like 20. We're doing a simple live stream just to demonstrate a concept, so I don't want this to take too much time. So I'm going to go ahead and run that again. And we can start to see where we are in terms of performance. This is an easy task, and so maybe it does pretty well. Oh, positional arguments are not allowed when calling dspy predict. Ah, okay. And so, so this by default, the way I used apply here, basically uses positional arguments. But dspy needs to know how to match the arguments I apply to the input fields. And so it's basically just telling me, hey, you need to use keywords so that, dspy knows how to match it back. So a simple way I can do this is I'm just going to get one value from this. And so I can just do that. And hopefully with 20 and using mini, it shouldn't take that long, even though I'm doing this sequentially. In practice, when you do something like this, you probably want to apply this in parallel because each LLM call can take some time. But I don't think that we need quite that overhead at the moment. Cool. And so I just want to point out, we have a really simple task. Just like tell us what is the emotion in the data set. And our accuracy here is only 30%. So already like we're like doing pretty bad. And so this might be a place where it's like, hey, actually we want we might want to improve that. And there's lots of different ways we can do that. I think optimizers are often kind of like the best way to go about it, and probably most aligned with the bitter lesson. So you'll hear a lot of people talk about the bitter lesson in AI, and it basically just means at the end of the day, really massive models that don't really have a lot of special domain specific tricks in them, but just are able to process massive amounts of data tend to do better in the long run. And so you can spend a lot of time trying to tweak how your AI model works for your specific problem, but very often there's something else that comes later that just works way better. And that lesson influences a lot of the design of DSPy. So anyway, so now we might want to apply an optimizer. And again, I said there's lots of different ways that you could go and improve this program from here. You can add instructions. You can add more clarification to these fields to explain to the LM what they are. You could use a different module. So chain of thought is another kind of module in which you like add a thinking or reasoning field. You could add there are modules that do like best of k predictions. So you do some kind of like you predict multiple things or output multiple labels and then take the majority rule. So there's lots of different things you can do here. I just want to talk about, hey, we might be in this place. We might want to apply an optimizer, but we don't really have, we're going to assume we don't have labels, even though we do have labels here. And so I'm going to go ahead and let's look at the DSPy documentation again. And so we have optimizers down here. And so optimizers, it'll tell you what several of them do. And it has a little guide that says which optimizer should you use. So if you only have very few examples, like 10, start with Bootstrap Few Shot. If you have more, you can like use Bootstrap. If you only want to do instruction optimization, if you're willing to use more inference calls and to perform longer optimization runs and have enough of data, like 200 examples, you can try Meet Pro V2. So we're just going to start with this Bootstrap Few. But at the end of the day, the thing that we should be trying to do is create a data flywheel. We want to make our generator work well enough that we can then use it to generate data that's good enough to later use in optimization. And there's a lot of considerations and concerns you should have behind that, but this is something that can help get you started in using optimizers. And so just given this, we're going to use Bootstrap Few Shot. And so this is sort of the quick example of how you use it. So I'm just going to copy that. And so and we don't want the random search variant. And then we'll go ahead and just basically wrap this up in a function for us. I don't know what arguments it needs to take yet. We're going to figure that out. So first, we're going to need a configuration. And really what I'm going to do is just add a config that's like whatever keyword arguments, and then we're just going to pass that through. So we'll say, and then we're going to say Bootstrap Few Shot. We're also going to need the Dspy program. And that's really going to be just this classify emotion thing up here. And then we're also going to need the train set. And so let's now look at the Bootstrap Few Shot. Oh, so they have some broken links. So let's see, where's the train set? Mhm. Okay, so I think the next thing we need to do is just find um, what the format of a train set is. Um, I think this is one thing that it's not very clear here. But it looks like we just need example objects. So this is pretty simple. So what I'm going to do here is basically create a quick data set of these examples to pass in. And so we can do something like create train set. And so maybe with this load data set, we'll do something like, this way we kind of like have a train and test sort of thing. Um, and so we'll go ahead and say DFTR, we'll call this DTR and DTE. And see, cool. And so we want to be able to create this train set. And so we're going to, wait, this should be the DTE. There we go. Cool. So we're going to basically output what is the unoptimized program's accuracy on the test data set. And then here, we're going to need to pass in train set. And we're going to have to come back here and ask ourselves how a metric is defined. I don't exactly know yet how we're going to define that metric, but we're basically just going to return this compiled program. And so then here, we'll basically say optimize program equals this. And we'll say train set equals create train set. And then we'll go ahead and say this. And so now we'll basically have what is the answer for the optimized. So now we just need to create the train test, the train set. And really all we need here is to basically return a dspy.example where we're going to iterate over and get the sentence and the sentiment through all the rows. So just as a slight note, a faster way to do this generally, because iterating by rows in pandas is really slow. So typically what you actually might want to do here is to use zip across the columns. So we'll say for sentence, if I can spell here, and then sentiment in zip, and then you take your data frame, sentence. Yeah, there you go. And so this usually ends up being a lot faster than just trying to use iter rows. Okay, so now we got our train set that we can pass in. And so now the only thing left to do is to define our metric. And again, we wanted this to be a human in a loop metric. So we'll actually even just make this take a metric. Cool. And so then the last thing that we're going to want to do is define And again, I don't know what this needs to take. I'm just assuming that a metric in Dspy is going to be a function. You can tell I'm not very familiar with Dspy. I just understand, I think, the underlying principles of it somewhat. And so I'm kind of floating through this and quite certain that we can do the thing that I'm showing you here. So Dspy metric is just a function in Python that takes an example and the output prediction from your Dspy program and outputs a float. And so this is basically, we actually don't even need this sentiment column because this is going to run it through the program, I think. But we'll just like leave it in there. But anyways, so it's going to take, oops, it's going to take an example and then a prediction. Cool. And so this is the place where I would basically make it this human in the loop because all that needs to happen is this needs to return a float. Did it say Boolean? Oh yeah. So we'll just return Boolean. And so what I would do is print example, and then I might even print out the example like that, and maybe we would even just put it on the next line. Oops, I can type. There we go. All right, cool. So we got that tabbed in. Cool. And so then what I would do is basically return input equals yes. And so, by the way, notice that there's ways to input wrong here, but basic idea is we can put whatever code we want in here. And so we can make it, if we wanted to, we could make this push out a request to an API and then have a UI where we go and label it and this waits until the answer comes back in or something. So that's all totally fine and dandy. So now we can go ahead, throw our metric in there. And so now let's see what we've messed up here. Okay, so we've messed up some things. So let's see. So first of all, we had 30% accuracy on that first 20 examples. And then remember, we switched the test set to the second 20 examples now, and we have 35% on that with the unoptimized program. So, okay, cool. Dspy teleprompt bootstrap failed to run or evaluate example. Input keys equals none. Due to inputs have not been set for this example, use example.with inputs to set them. I really love that the error told me exactly what the issue was. And so it looks like we need to use example.with inputs. Let me just like look at this real quick just to see an example of this in like real code. Okay, yeah. So you just do dot with inputs and then you specify what the field is like that. Cool. And so now we have example objects where we have both the input and output, and we've specified what the input is. I do have like one sort of like question in the back of my head in that we're always optimizing something that breaks down to a signature at the end of the day. So it's a little silly that we have to specify this at this level. It should be inferred from here. So that's a place where I think the API of Dspy could definitely be cleaned up. But for now, we will suffer. So we see it's starting to do some kind of like optimization, um, but we see it come and take this HITL metric takes two positional arguments, but three were given. And I think this is because I only gave it two arguments, but I think there's a trace argument that it will technically pass. Um, I didn't really have that. And so now we see that I get the example printed out, I get the prediction, and then is this correct? And so the prediction here is sadness. Um, so it unfortunately later died from eating tainted meat. Name BBC documentary dynasties followed the Marsh Pride the Lion episode was awesome. This is really difficult because it has something that's sad in the beginning and something that is happy later. So I would kind of just maybe say this like cancels out and is neutral. So I'm going to go ahead and say no. The next one says last time I saw was long ago, basically before Ellen announced they went for probabilistic routing. Yeah, I think that's pretty neutral. And I'll scroll up here too, just so we can like see all the different things we can have. Um, so I don't see anything about that feels love, disgust, confusion. Arguably, maybe you could say confusion or surprise. Um, but so I'm going to go ahead and say, yeah, that's right. You mean by number of military personnel? Because if you go by Navy size or budget, that's not even remotely true. Um, I wouldn't say that this is anger, but I would say that this is probably like confusion or surprise. I'm going to go with confusion, but you know, I would still say anger is wrong. Um, need to go middle of the road. No name is going to vote for name. I wouldn't say that this is anger. This could be surprise, but this doesn't come across as angry to me. So I'm going to say no. Feel melty, miserable enough, imagine must. Yeah, I think that it's fair to call this. A lot of these like are very weird, and so I'm like even starting to wonder like where these come from. Uh, but I'll go ahead and say yes on that. Example: feel sense relief, also sadness. End colleagues anyway. Fab. This says sadness directly, but I actually feel like this is one that is like more happy. So I'm gonna just say no on that. So think get feel weird ones use dryers all the time. Use dryers time. I'm definitely confused reading this one, but I don't know that this conveys confusion. If your host stand has a register that isn't locked securely, you have bigger problems than this lady, I think. One of the funny things I see in these, I feel like direct communication is being inferred as anger, and I think that that's like often a problem humans have too. So if your host stand has a reddish that isn't locked securely, so I wouldn't say that that's anger. Oh, someone finally posted something I can't bring myself to finish reading. It's too much. I feel like this might be like more sarcasm than disgust. Feel presence beloved behind tilt neck, side smile, feel lips, shoulder. I think it's fair to call that love. Maybe also desire, you would say. Did I? Well, anyway, you'll get your raise when the economy starts picking up. I think it might be fair to call this sarcasm. You might also call it confusion or surprise, but I think sarcasm. Actually, I'm gonna call this no because that might not be sarcasm. Sarcasm is really hard to tell in just text only. I hang my head down and feel even more embarrassed to complain about such minor things in my life when others are having a hard time just surviving minute to minute of the day. I think that's a really great prediction. Shame. Um, so bootstrapped four full traces after 12 examples for up to one round, amounting to 12 attempts. And so we can see after going through that, we basically improved our score, from 0.35 to zero point 0.4. And maybe you're thinking like, wow, that is not enough. But I would also, say that going from 0.35 and having like a 5% improvement from just like a little bit of work is pretty good. It's not bad. And definitely there's lots of other things, again, we could do to optimize this program. We can add more instructions. I think like the most interesting way to use Dspy, once you start getting into the place where you've saturated what you can get from adding sort of instructions and some more detail in your signature about what all the fields are, I think the really fascinating thing is when you use a Dspy program as your metric, this is effectively AI as a judge and how you would do it in Dspy. And so from there, you can essentially have a Dspy program that's helping to optimize your main Dspy program. And then you can apply the same technique we just applied to ensure that you're improving your AI judge as well. And then you use that AI judge to improve your main program. So I just wanted to show this as kind of like a cute thing you can do with Dspy. I think Dspy is a cool library. There's a lot of, for me, rough edges, and so it's not something that I personally am comfortable recommending to clients I work with yet. Um, but I am very excited to see what happens with it, and I'm very excited for the latest 3.0 release that just came out. Excited to learn more about it and see if it addresses some of the concerns that I have with it. But thanks for watching. Catch you later.